Hello and welcome everybody to Udacity's Robotics Q&A. I'm Mike Salem and I'm here with CEO and co-founder of Traptic, Lewis Anderson. Lewis, how are you?
Doing well today, thank you.
Great, nice to have you in studio.
Yeah, I'm really excited to be here. It's always fun to talk to a bunch of people excited about robotics.
Definitely. So I wanted to talk to you a little bit about Traptic. So what exactly is Traptic doing?
We are developing a strawberry harvest machine.
Okay.
So basically, agriculture is facing this really serious labor shortage where they can't find enough people to pick the strawberries. So they can grow the strawberries in whatever quantity they want, but they can't find enough people to pick them. So a lot of growers are having to leave some percentage, 10, 20, 30% of their field unharvested in the peak season, especially the end of the season. And this labor shortage is supposed to get a lot worse. And this labor is supposed to get a lot more expensive. So this is a threat it's threatening to drive them out of business. So we solved this problem by developing a machine that can harvest strawberries. We use robot arms, 3D cameras, powerful computers, along with AI, computer vision, custom gripper, to develop a machine that you bolt to the back of a tractor, you drive it up and down the field, and it picks strawberries.
Interesting. So before we jump really into some of the more specifics of your actual company, what's your background? Where did you come from prior to doing robotics for, let's say, for your company?
That's a good question. So I did, just before this, I was working at Microsoft. I was there for 3 years working on PowerPoint and on the Office build system, doing non-robotics, non-computer vision stuff. Right. Before that, I did a computer science degree at UCSD, so UC San Diego, and I worked on an autonomous airplane team there. So this was for a student competition where we built and flew an airplane that flew itself, did kind of an aerial surveillance competition, did a lot of computer vision for that in some classes, and that was kind of my first real exposure to taking these really cool software ideas and getting them out into the real world, interacting with the real world where you can have a bigger impact.
Interesting, interesting. So you came from more of a software background, kind of getting into robotics versus more of a hardware background.
Correct, I was totally software.
It seems like most people I end up talking to usually come from a mechanical engineering background first or electrical engineering, and then they kind of move in. What was that experience like for you, kind of coming from the software world and kind of slowly learning like the more mechanical, electrical side of things?
It was super hard. People say hardware is hard, it's totally true. So I think the first thing I did was I got a 3D camera. So I'd been talking to customers to figure out whether this was something that people wanted. I think that's always the first step, is make sure there's a need for this.
Right.
So then I bought a 3D camera and was carrying it around the strawberry fields trying to do this, write software that would identify ripe strawberries. And I was like, okay, and I got it working. I was like, this is great. It's the hardest part. Now I need to go pick them. And so I started going online looking for robot arms, and I bought one. And I had this robot arm in my hand, and the 3D camera. I was like, okay, well, how do I put these together? So I had to build a frame, all this other stuff, and I was really bad at it. And honestly, my solution was to bring my co-founder on board because he's a hardware guy.
Right, great guy, by the way.
Yeah. So Vin joined pretty soon after I started doing this, and since then he's done all the hardware, and that was really a lot better. He has a mechanical engineering background.
Sure. So it's nice. So this is an example of an interdisciplinary type of field, right? So somebody who's purely a software-based person, or more of a software bent. I shouldn't say purely software-based, but more of a software bent, tend to require other skills like mechanical skills or electrical skills, or even in some cases designers, right, to kind of come in and bring all of these things together. So it's really nice to kind of see how it's a big melding pot for everybody to kind of get involved.
Yeah, and I think that if you're doing like a hobby level project, it's fun to do all of it because you can learn a bunch and that's exciting and it's challenging. I think if you want to commercialize it, really it's good to get a bunch of people together with different skill sets. At least like 2 or 3 people. Someone's good at software, someone's good at hardware, because you can just accomplish so much more that way. And really everyone ends up doing a little bit of everything because you're working so closely together.
So what's typically your favorite application as far as what you're working on for the robot yourself? So I know it sounds like you've actually went and sourced some commercial off-the-shelf parts, like a robotic arm, but I know a lot of your hardware stack, your software stack is probably built in-house. You're probably doing a lot of work to kind of make sure everything stitches together seamlessly. What's your favorite part of kind of the software realm? What do you typically like to do?
Favorite part of the software realm? I think the most exciting part is getting things to work. I care a little bit less about how stuff gets done, but when I see all the pieces work together, that's really awesome. So I try really, really hard to use off-the-shelf things. So for hardware that's going, to a store to buy something or to a hardware provider to buy something, For software that's using open source libraries, using existing data sets, basically using as much stuff as you can that other people have built. Obviously stuff that's freely available, make sure you respect the licenses, but trying to build as little as possible yourself. I think that when you have good engineers, they get excited about building things, and you have to be careful to make sure you don't build too much and don't like reinvent things that already exist. In terms of other things we've actually had to build, so we use neural networks. So we get we take a bunch of images of the strawberry field on a very rapid cadence, and we have to identify ripe strawberries in them. So a ripe strawberry is entirely red. So a strawberry that's partially red, partially green is not ripe. Strawberry that's entirely white is not ripe. So we use a neural network to find those ripe strawberries. And I think training the neural network was really fun in kind of a weird way, because it seemed like this hard problem to like write something that would do this. But then I got the data set together in the right way. I used people on Mechanical Turk. So first of all, I went and I captured all the data myself. And then I used people on Mechanical Turk to label the data set.
So can you explain what Mechanical Turk is for some of those people who aren't really familiar with it? It's actually a great resource.
It's really cool. So it's this service that Amazon runs, so Amazon Mechanical Turk, where basically there's a bunch of people behind this, and you submit tasks that are good for humans to do. And the humans will do these tasks, and you get the results. And so you can, and they have a large group of people, so you can take a task and run it like 1 million times and get the result in 24 hours. And you don't have to manage the people, you just set it up on this web interface, and they handle the management, and they charge you for the time.
So that's a great tool to have if you're kind of a small, agile company that's trying to get going, and you need a lot of resources kind of quickly to do kind of a mundane level task. You can kind of go to this Mechanical Turk and say, help me out really quick, they get paid, you get the results that you need, and you can kind of move forward. Yeah,
you can get this massive scale for a short period of time without having to worry about hiring all these people.
Very cool.
It's really useful.
So what else in your tool chain? I know you talked about a little bit of doing neural networks. I'm assuming convolutional neural nets because you're talking about images. You're using Amazon to kind of help classify. What kind of tools, what kind of tool chain, what kind of programming languages are you typically using? What kind of software tools are you using to accommodate those languages? Yeah,
so in terms of our stack, so we do almost everything on Linux. A couple of the libraries we use are Linux only, so that is why we use Linux. So we use Python and C++ as the two languages.
Okay.
Initially, I tried to do a lot of stuff in Python, slowly porting more of it to C++ for performance reasons, and so it can all be kind of in one language. We use OpenCV quite heavily. We use Point Cloud Library a fair amount. We use ROS for communicating between our Python and C++ nodes. Let's see. On the neural network side, we're using Caffe for that.
Interesting. Okay.
Let's see.
Was there a reason for Caffe over something like, let's say, Keras or TensorFlow or Theano or?
Yeah, there's a specific neural network that we wanted to use, and someone had built it on top of Caffe.
Okay, great. So that's going back to your original point of trying not to reinvent the wheel, right?
Absolutely.
Looking at the tools that are available for you at the beginning and trying to utilize those tools to the maximum potential. And then that way you can get going on the problem that you actually want to solve instead of trying to build a solution to solve the problem from the very beginning.
Yeah, like you have to look at what part of your solution is unique to you, and try to focus all your time on solving that and making that really cool, and spend less time on redoing things that other people have done. And so the really cool thing about using that open source code was once I got the data labeled and like all together in a folder in the right format, I was able to get the neural network to do what I wanted in like 3 days.
Very cool.
Yeah, and it was like what I thought was a reasonably hard computer vision challenge, and just solved just like that. It was pretty fast, it was reliable.
So let me ask you a question about some of the data that you captured. So obviously you were taking, it sounds like you were doing RGBD type of images, right?
Yeah.
How many images do you have of strawberries?
Way too many. So I think our
Can you give a rough count, thousands, tens of thousands?
I think when we trained the neural network, we had thousands of berries.
Wow. So you have to have berries that are both ripe and unripe, right? Because you have to be able to identify in a network that this is a good berry versus this is a bad berry.
Yeah, so what we actually did is we took images of sections of the field. I'm pretty close up, so maybe like 4 or 5 feet of a row. And we had people in Mechanical Turk draw a box around the ripe strawberries. And we just did nothing with the unripe ones. And the neural network just learned to ignore those.
Perfect. That's a great approach for actually solving that problem.
Yeah.
So let's talk a little bit about your robot grasper a little.
Okay.
So I know you said you bought this thing as commercial off the shelf, and I know some people actually in our Slack community had some concerns about, well, how do you know if you're applying the right amount of force and pressure to kind of pull these things off? How do you not crush these berries as you're bringing them in? What kind of challenges did you kind of see when you first started working with your robotic arm?
That's a good question. So there's kind of 2 separate components there. There's the gripper itself that actually touches the berries and is mounted kind of on like a little stick. And then there's the robot arm that actually moves it into the right position. For the robot arm itself, the very first one we got, it was like $200. It was a hobbyist 6-axis arm. And then once we raised our first round of funding, we bought an arm on eBay, a 4-axis SCAR arm that I think had sat in a 3M factory for like 10 years.
Okay.
So doing the delicacy is a little challenging because the robots we're using are not collaborative robots. So a collaborative robot, if you apply enough force to it, it'll stop. So it's kind of safe to be around.
Okay.
Ours will just, you tell it to go to position, it will go there regardless of what's in the way.
Okay.
So you really have to be careful. So we really have to be careful on the vision side to tell it where it's okay to go and where it's not. The vision, the path planning, so that the path we give it is safe to go to. And then on the gripper itself, in terms of not smashing it, the initial idea that we had was to use pressure sensors for that. So you close until you have a certain amount of force, then you stop.
Right.
But those didn't work as well as we thought they would. So actually the jury is still out on whether we use those or not. Some of the other ways is just designing hardware that will kind of automatically conform to the shape of an object in a way that kind of applies even pressure, doesn't squeeze too hard.
Something like almost like a foam kind of insulator to kind of help cusp it basically, right? And then apply enough force that nothing gets damaged.
Yep.
Interesting. Very cool. With regards to moving your arm, you said that there's really no real like safety stop, right? So if I were to move the arm, if I were to give it some sort of motion path, plan out the path, and it executes this path, and let's say a person's in the way, a person's going to, potentially, depending on how strong the arm is, knock them down or get them injured. Oftentimes with a strawberry bush, there might be a strawberry that's kind of a little bit further back than, right at the front, where it's a ripe strawberry. How would your arm go about trying to find one of those strawberries? Is that a challenge? Is that something that you kind of say, well, we'll just leave this one on the vine for now and kind of revisit this, or?
It is a challenge. So what we do there is, first of all, the strawberry plants themselves they're weirdly like flexible and durable. So you can kind of run an arm through them pretty fast, like pretty low off the ground, and like it'll hit a bunch of leaves and stems and stuff. It won't damage the plant at all. So kind of if you're hitting some leaves on the way to the berry, that's okay. The one thing we have to keep in mind is that if you have like a plant here and a berry here and you approach from this side, if you like are hitting the plant, that'll move the berry. And then you end up trying to grab where the berry was rather than where it is, so it'll miss. So we kind of try to be clever about the path we follow to get there.
Gotcha.
But our solution is a lot simpler than we initially thought it would have to be.
Well, that's great.
I think one of the surprising things about robotics is, like at the beginning, I sat down, I tried to think of all the hard problems, like what's going to be hard and what's going to be easy.
Right.
And then now looking back, the list was totally wrong. Like a lot of things we thought would be really hard, we solved quickly, and then things that we had never thought of would be issues end up being hard.
So can you talk about some of those issues that you thought were hard that you didn't really think they were going to be?
Yeah, I think identifying the ripe strawberries was one of them. Kind of that open source neural network that we use just magically solved that problem. What else was easy? The second thing was our goal is to pick a strawberry per second per robot arm. So we're going to build a machine that you bolt to the back of a tractor, has a bunch of arms on it.
Right.
You 4 to 8 robot arms. Each arm has a gripper. And we want each of those arms to be picking a berry per second, all going in parallel. So they're picking pretty fast. And basically the only hardware out there that would work was robot arms intended for factory use. So these are big, heavy things that you bolt to the floor.
Right.
They're in a relatively clean environment. There's no vibration. There's not much water. And so we knew, okay, that's the arm we want. It has amazing specs. They last for like 30,000 hours of continuous use. And we want to get it out in the field where it's like there's lots of vibration. We're mounting it to a much smaller object, and there's potential dust and dirt and water. And so, you know, is that going to be a problem? We were afraid that like they just wouldn't work out there. And so far, that part was relatively easy. We started to make sure we buy arms that have the right environmental rating against dust and water. And they sort of just work.
So what are some of the harder problems that you face that you thought would be easy?
I think building a frame.
Really?
One of those, yeah.
So why is that?
So we have all these components, and we need to put them in the right place. And they're kind of heavy, and so you need a frame that can support their weight. So the frame ends up being kind of heavy. In the initial version of the frame, we didn't want to involve a tractor because we didn't want to take up too much of our customers' time when we were doing our initial tests.
Sure.
So it just has like a big frame that has 4 wheels on it. And it's like 10 feet long, like 6 or 7 feet wide, and it weighs like 500 pounds. And so then we push it by hand through the row. What we figured out is it takes basically all 3 of us. If it's like at all muddy, it takes all 3 of us to move this thing. So you sit there like pushing on it really hard, just trying to get it to move in the field.
So you're skipping your gym days and days that you're out doing field
testing.
testing.
Yeah. Don't need to exercise.
So the frame was actually one of the things that you thought would actually be really easy that turned out to be a lot more complicated because you had weight restrictions and trying to figure out maneuverability once you're out in the field.
Yeah, weight and durability. And also these arms that we're buying are really fast. So we want to be able to do faster than a berry per second. So it's like something like this pace, but moving over like possibly a meter. So moving over 3/4 of a meter and going down to grab something and then moving back all in a second. These are relatively heavy. And so when they do that, they accelerate really quickly. And so a heavy thing accelerating quickly puts a lot of force on the frame. So you also need a frame that can withstand that force and provide a relatively stable mount without falling over or falling apart or anything like that.
Definitely. I can see the challenges there. So you talked about having like a 3-person team, right? So is having a small team, do you feel it's advantageous at this stage, or do you feel like, you know, having a couple other members would make, you know, the load a little bit easier? What's it like being kind of like, I would say startup stage, right? So what's it kind of like being a startup right now in Silicon Valley and robotics?
Super exciting. I think working on a small team is really fun because you're all in the same place. You can talk really easily, bounce ideas off each other and try crazy things. I think our team is definitely the right size right now. We have the necessary hardware and software skill set. And in terms of team size, it's sort of a trade-off between how quickly you can get stuff done and how much money you need to raise.
Sure.
So in our case, we all want salaries because we have to pay rent and eat food occasionally.
Yes. Living in the Bay Area is definitely expensive, right?
High cost of living here.
Yes, absolutely.
So, and if we hire more people, then that shortens our runway. If we have less people, then we have a much longer runway, or we can raise less money, which means less dilution, typically. But then less people get less stuff done. I think 3 people feels like a really good
for where you guys are at right now.
Yeah.
So really good, lean, and
so
easy to tackle all problems.
Yeah. So we brought Brian on board, who's our 3rd person, about 2 or 3 months ago. So he and Vin and I worked together on the airplane team. So we'd all worked together before.
Sure. So you already have chemistry, you already have a dynamic, you know how to work with each other.
Yeah, and I think that's super important. If you can, like this isn't always possible, but if you can get people you've worked with before, that really reduces the risk in terms of whether you're going to have personality or communication conflicts on the team. So he joined 2 months, so it was like just me for a few months, and then Vin joined, it was Vin and I for like 6 months, and then he joined. And we really saw our, each time, like when Vin joined and then when Brian joined, we saw big jumps in productivity. like I swear when we went from 2 to 3 people, I think our productivity like doubled or tripled.
Oh, that's a good return on investment, right?
Yeah, and you expect, okay, if you're increasing your workforce by 50%, you probably get 50% more done, assuming you scale well, but we actually saw a much like better output than that. So I think that's possible if people work together well.
Interesting. So small teams are always kind of good to start out with, and if you need to add people, it's easier to add, knowing that your workload's kind of set up for you in the future.
Exactly.
More or less.
Yeah. If you scale to like 6 or 7 people relatively early, you have to raise a lot of money, or you only have like 6 months of runway.
Sure.
Which means you don't have enough time to build the technology.
So what's it like trying to raise money for a robotics startup?
It's a good question.
How did you go about it for your first round, if I can ask that question?
You can, yeah.
Okay.
So we raised $400,000 from K9 Ventures, which is a micro VC in this area. And that was back in October. So the way I went about that process is I tried to build a list of all the investors that I thought would be good candidates for investing in us. I tried to find people that had done robotics or some kind of hardware startups before. Because really, getting investment as a hardware startup is a bit harder than as a software one. In our case, we think a lot of our challenge is software, so we're still a good fit there. But a lot of investors won't really touch hardware. So I tried to come up with a list of investors that had invested in hardware startups or said on their website that they were willing to do that. And then I paid for the premium LinkedIn thing for like a month, and I went through all these people and I tried to figure out what connections we had in common. And so I figured out which of this list of investors I had second-degree connections with.
Okay.
And then it was like probably the most emotionally challenging step of the whole process is I went to each of these to like our shared connection. A lot of times these were people maybe that I worked with recently, but some of them I hadn't worked with in a long time.
Right.
People from college or previous jobs. And I just sent an email and asked, hey, like I see that you're connected to this person. Would you be comfortable doing a quick email intro?
Sure.
And the really cool part of that process is I got a really good response from that. I think people are super helpful. I think as long as you're respectful, polite.
Right. Professional.
Professional, yeah. People are really willing to help. And so a lot of people made that intro. And getting a warm intro from investors is really important. I think it's probably necessary in the vast majority of cases. So then you get this email intro and I'd send a short blurb about the company, and then some percentage of the investors were willing to meet, and so we'd meet and kind of go from there.
So what was it like as far as what would you tell investors? I mean, did you have a product at that point? Did you have a proof of concept? Did you have just kind of an idea that was still in your head? Like, I want to build a strawberry picking robot. And the investors were like, well, do you have a proof of concept, or do you have some simulation? What was your approach, your method kind of going?
So it's a good question. Most of the things that I've heard say that it's really hard to raise investment if you don't have some kind of prototype to show. I think some people can do it. Like if people have done a successful startup before, then they can raise a first round with basically just a pitch deck. But in our case, we built a prototype. It was a really early prototype. We had a video of it picking a couple strawberries in a real field, so it kind of showed the whole system working together. So we had that proof that we could, even if it wasn't like quite what the final product was going to be, we proved that we could do something.
Right, it's not a pipe dream. You actually have something that you can show that you can iterate on.
Yeah. So with K9, the first meeting we had was at their office, and then for the second meeting, they came to our garage, and we could show them our robot in person. That was fun. The other half of the pitch that we made, we had statements of support from 4 strawberry growers and then a pepper grower. So these are letters that the growers wrote, basically non-binding things saying, hey, we talked to Lewis. We think this is a great idea. We are super interested in paying for this as soon as it becomes available. And we showed these to all the investors, and it demonstrated that there was a need for this. So ideally, you get like some kind. You really want proof of some kind of customer traction. Ideally, a prototype or beta that's like out in the field generating revenue. But in our case, that wasn't an option. So we had these letters, and that really went a long way towards proving that we'd talked to these people, that they were receptive, that they really wanted this, and that there was a big enough market for it.
So when you talk to these farmers or these customers, if you will, the strawberry ones and the pepper one, how would they end up utilizing your product in the end? Would they end up purchasing your product, or would they end up renting your product? What's kind of the strategy going forward for once this is actually deployed?
Yeah, so our strategy is harvest as a service.
Okay.
So we build this machine, put it out in their fields, and they pay either per month of usage or per pound of strawberries that it picks.
Okay.
So currently they pay their human workforce on a piece rate basis, so they pay a certain amount for every pound of strawberries. So we would just charge the same way. And this is really awesome because, first of all, there's a very low barrier to entry when they first start using it.
Mm-hmm.
If you try to convince someone to fork over $1 million before having seen anything at all, like they're not going to do that.
Right.
Or maybe it's going to just take a really long time. But if you say, okay, you don't have to pay anything, put it in the field. After 2 weeks, if it's working, you pay us. Otherwise, you don't. It's super low risk for the customers, and they feel comfortable with it. It also ensures that long term you have a recurring revenue stream.
Right.
So that you're not constantly having to make new sales. I mean, you are making new sales, but
you're renting out your product again for reuse.
Exactly.
As needed or in demand basis.
Yeah, and then at the end of the day, it really makes it so that everyone's incentives are aligned.
Mm-hmm.
Our incentives are to make sure that our product is working just as well or better, after 3 years in the field as it was the first day we deployed it. If you sell something for an upfront payment and charge more for maintenance,
Sure.
there's potentially weird incentives. But in this case, it's...
And it actually keeps your costs down a lot too, right? Because you don't have to go through this big manufacturing process of, maybe sending out, 5,000 or 10,000 robotic arms. You might be able to cut that down to, let's say, 1,000 or 2,000 robotic arms.
Yeah.
Allow you to reiterate, make improvements, right?
Yeah, and the fast iteration is also a really important thing. So if we own the machines, we can swap hardware components whenever we want, mid-season. We can push software updates over the air every night. So we can keep iterating on these really quickly. If you do upfront sales, you get to iterate every time you sell a new unit. But if you're owning these and doing it as a service, you can iterate every day if you want.
Sure.
That's a lot better.
So you talked briefly about this pepper, and I'm kind of fixated in my mind now because you're strawberry picking,
Yeah.
right? That's your goal right now.
Yeah.
Any goals to move into peppers or
So
changing to different fruits or vegetables or?
Yeah. So the business problems that strawberry growers are having around their labor, in terms of the labor availability primarily, growers and other crops are facing the same problems. So something like half of fruits and vegetables are not automated in terms of the harvest. And the harvest is super expensive. So it accounts for something like 30% of the total cost of producing the fruit or vegetable. So of the total cost, the land and the fertilizer and the water and all that, of that, a third of it is just the manual labor to pick the crop. And this problem is faced by about half of fruits and vegetables. And so our long-term plan is to do strawberries first and then slowly expand into other crops. And so I wanted to show that there was indeed some demand from at least one grower outside, and there was a pepper grower nearby that I got introduced to, so that was pretty easy.
Interesting. So it sounds like you can use virtually the same hardware as well, right? Your software might take a slight modification in your neural net because you would have to train for peppers, let's say, instead of strawberries.
Yeah.
But it's essentially more or less the same idea.
That's a good question. I think so, yeah. You want to reuse as much as possible. I think Vin and Brian might disagree with me on that. They might say there's more hardware changes needed than that to switch between crops.
Try not to upset your coworkers,
Yeah.
your co-founder.
I'm going to promise that they're going to do all kinds of things.
So if I'm an aspiring roboticist, if I'm somebody who's kind of interested in getting into the field, what's my path to entry in your perspective?
That's a good question.
What are the necessary steps that I can start taking now to kind of say, I have this idea, I have this dream in my head, I want to build this robot, and I want to take it all the way to market, and I want to pitch it to somebody, and I want to start my company?
That's a good question. I would say you probably need to make sure you have the technical skills necessary.
Sure.
Obviously, make sure you can code. If you're on the software side, make sure you can do any of the machine learning or the computer vision stuff that you need. Same on the hardware side. If you want to do it if you want to build a commercial product, that means to me probably doing it as a startup. Like there's other ways to do it, but that's probably the most common.
Right.
And I think the path there It's sort of the same as other startups. So the most important thing is to make sure there's a need for it. Make sure that there's customer interest, and to prove that customer interest in some way. Statements of support from customers are great, or interviews with people, or some kind of evidence that not only is there a problem, but that people will accept your solution.
Sure. Do your market research as well.
Exactly.
Right?
Yeah.
So, just because it might be a great robot, it might be a great final product, but if there's no demand for it, it's going to be very hard to get funding typically.
Yeah, you need to make sure there's a demand. You also need to make sure the business model works. So you figure out when you deploy this, what's your return on investment going to be? How long does it take to pay back your capital investment? So do that. And then come on the technical side, building a prototype is useful. Try to build the worst prototype you can imagine, the simplest, hackiest.
Right.
Just something that proves that the idea is kind of plausible. And then get it out there. Maybe raise a round of funding, find people to work with you. So the first 2 to 4 months I did this, I was by myself, and I don't recommend that. I think being a solo founder really sucks.
Sure.
It's really lonely, actually. It's a lot more fun to be working with someone.
Yeah, I definitely could see that. It's nice to have other ideas coming in, being able to collaborate, bring different things to the table.
Exactly. You get much more varied ideas. And it's not always practical for everyone to find a co-founder.
Sure.
Sometimes you want to make sure you've worked with the person before, and sometimes you go to all your friends and none of them are interested in doing a startup, and so you're like, okay, I'll do it by myself, and that's fine.
Right. So the agriculture space, in agricultural robotics in general, right? There's starting to be a lot of buzz, right? And there's other companies that are in this realm.
Yes.
Are you looking to expand into? First of all, let me ask this question, I guess. How do you differentiate yourself from some of your competitors? I know there's some competitors. There's a company in Spain that does a strawberry picking robot as well. How do you differentiate yourself in the market from somebody like, let's say, someone doing a lettuce bot or a weeding bot, or picking potatoes or something like that?
That's a good question. So there's 2 answers to that. First of all, there's a bunch of companies doing agricultural robotics that are not strawberry harvest. Those companies are definitely not at all our competitors. So there's such an enormous number of opportunities in agriculture that there's room for a ton of companies to go after this. So I see a lot of these companies as collaborators. There's lettuce thinning. There's a apple harvesting company. There's others, and we really see them as potential collaborators and allies, and not at all as competitors. In terms of the couple companies going after strawberry harvest, there are more of competitors to us. And so one of the big differentiating factors for us, first of all, is that we want to make it so that you can deploy this machine in a field as is, with no growing changes necessary. So same breed of plant, same shape and size of beds, same density. So you can throw this machine out there in the middle of the season with, no prep if you want. So the Spanish company, Agrobot, they require you to grow in a different configuration. That means you have much lower plant density, having lower yield, and so it ends up being a lot more expensive to grow overall. In terms of our solution, we'll be able to deploy it in traditional fields, which means you get all the economic benefits of this really efficient growing system that they have, and you can self-harvest.
Interesting. So yeah, I noticed that some other companies, they have more of their robots still require a lot more human intervention, it sounds like, than what you're offering, right? Yours is more of only pick the ripe strawberry and put it down, versus more of a sweeping way of picking up a bunch of strawberries and still having a human sift them before packaging.
Yeah. And so it's important to clarify that we do see this still as labor augmentation. Our goal is not to replace all the labor, is to augment it. So we probably, especially for the first little while, will miss some percentage of the fruit. So they'll send humans through afterwards to kind of clean up the stuff we missed. So our goal is to make so the growers can take their workforce, which is naturally shrinking in supply, and grow more strawberries. So increase their yield with decreasing labor. So we think that if we deploy that, we'll just really naturally solve this problem. Everyone who wants a job will still have one, but at the same time, the growers' businesses will do well.
Interesting, great. So let me go ahead and take some questions from our Slack community.
Cool.
So we have lots of questions actually this week for you, which is great.
All right.
So
Exciting.
Let me go ahead and pull up a few of them. So here's one from YouTube. Which neural network from Cafe Zoo is Lewis implementing / using?
So we're using faster RCNN. There's a Pi faster RCNN implementation. I don't know that it's in Cafe Zoo, but it's available on GitHub.
Okay, great. So I have another question here from Anne. To detect ripe berries, is there any deep learning involved to get precise color of the fruit to pick? Is there any plan to put the robot arm on wheels so it can autonomously move row to row inspecting on fruit to pick?
So in terms of the autonomous driving, so our machine will bolt to a tractor. And that's really important because we don't want to solve the navigation challenges. Like navigation and propulsion is kind of hard. And there's the farmers are already really good at taking these big, heavy machines and moving them all over their field.
Sure.
We think that the right path long-term towards autonomous navigation of our system is probably to make the tractors themselves autonomous. And we see that as somebody else's job. Yeah, and the first part of the question was about deep learning on the color.
Correct.
Yeah, so the input to our neural network is RGB image. So it does take the color, and then it just figures out what to do with that.
Great.
Via some neural network magic that nobody understands.
Okay. So I have a bunch of questions here.
Okay.
From Matthew Zimmer, excuse me. So we'll go through them one at a time, so that way you're not bombarded and you have to remember all of them.
So I should get my notebook out right now.
You could. What's the first step one should take to get enough investment capital to stay afloat for a couple of years to build a full-scale prototype?
That's a good question. So I think the typical like pre-seed investment is going to be somewhere between $250,000 and $750,000. And so if you have 2 people, that might last you, 1 to 2 years.
Right. In Silicon Valley, of course.
Silicon Valley,
yes.
Yeah. If you're outside Silicon Valley, your cost of living is lower, but I think it's also harder to get investment. There's also less like ecosystem support for startups. In terms of the first step to getting that investment, I talked a lot about making sure you have proof of customer interest.
Right.
When you actually start the fundraising process, making sure you have a good pitch deck and a business plan is important. Like a business plan is like a 15 to 25-page document. And writing it seems awful and stupid, and you're like, why am I wasting my time with this? But it actually forces you to write down like every step of the process, write down all the details of your business model, who you're going to hire, when and how fast you're going to grow. And it forces you to add a degree of rigor to your pitch and your startup that didn't exist before.
Great.
I thought it was hard, but it was really useful.
Good to know. So the next question is, should I file patents first and then work on pitching the idea to investors?
So patents are super expensive. It costs like $10,000 to $20,000 to file a patent. The best answer, so I don't really know the exact answer, the right answer to this question. The best advice I've heard is that you have to think about what's most likely to kill the company. So in terms of, so you sit in your room and you have this idea, you look at what happens between then and like having this big company with a product out in the market. There's a whole bunch of ways where you can fail. You have to look at what are the most likely ones. Like maybe you can't make the right hires, maybe your customers aren't interested, technology doesn't work, can't raise money. There's a whole bunch of things.
Sure.
And someone like stealing your technology and implementing the same thing, in my opinion, is very low on the list. So a patent is about like defending yourself from direct competitors. So you probably shouldn't be focusing on that. You should probably be focusing on making your business better and file patents later.
Great. So for robotics projects, are software simulations sufficient for pitching a new-to-market product? And again, obviously, this is your opinion.
Yeah, I doubt it. I think you need, if it's like a robotics startup that's going to have hardware, I think you probably need some hardware.
So what are
definitely having hardware is a lot better.
Yeah, definitely, right? It makes it easier to kind of show something that's physical that people can actually interact with.
Yeah, and I think especially in the demo, you want to make it so people who look at your demo need some amount of imagination to like see how it's going to actually work in the final product. You want to make it so that they need as little imagination as possible. So they look at your thing and it's really obvious how it works. And if they have something they can like hold in their hands or grab, it
makes it a lot easier. So what are some of the greatest risks you take as a robotics startup? In terms of a robotics startup compared to other startups, I think funding is harder.
Getting funding is harder, and hardware is more expensive. Like the most recent arm that we bought was like on the order of $30,000. So you need more capital there, and also like physical things break. It's really weird. Like software normally doesn't just randomly break, but like you can have like a wire that just snaps and then like something doesn't work, like a camera that just breaks.
Right.
So you have to be prepared for that.
Yeah. It usually happens during demos too, which is always the most exciting thing in the world, right?
Yeah, always the worst time.
Everything works until the day of.
Yeah.
So this next question here is from RP. He says, your gripper has no cutting tool for the stem. There are a lot of very similar harvesting problems, berries, tomorrows, and agriculture. Which require a cutter, and in my experience, some strawberries do too. Have you approached R&D on the picking process?
So in terms of cutting the stem, so when you buy strawberries in the store, they basically never have stems in the US. I think in Europe they a lot of times do. So one of our big goals is to make it so that growers can deploy this machine in the middle of the season and just start using it with zero barriers to entry. And their whole supply chain is built around the assumption that there will be no stems. And so if you start producing strawberries with stems, they need to go change their supply chain. And it's probably not like a impossible thing for them to do, but like then there's this big like barrier to entry. So we want to make sure that our strawberries don't have stems from day one. So we make so that when you grass the berry, we pull it off the plant and the stem naturally breaks off and there's no stem.
Gotcha.
Yeah.
So next question is, you appear to be using the real-time point cloud for identification and positioning. It looks like you're doing a fair bit of cropping to optimize the processing workload. Can you go into any detail on the specifics of your optimized CV workflow beyond the standard photogrammetry?
Yeah. So the first version of the software I built converted the entire image into a point cloud, and there was like, I don't know, like millions of points, and it was super slow. And so that was a problem. So what the current version does is it takes the entire, so we're using Kinect cameras, the most recent Kinect camera, and it produces a RGBD image. So we take the entire RGB image and we give that to the neural network, and it draws a little bounding box around the strawberry. And then we expand that bounding box a little bit, and then for the rest of the process, we only ever look at that part of the image. So we convert that part of the image into a point cloud, and now rather than having millions of points, we have like hundreds or thousands.
Sure.
And then the rest of the computation is really fast.
Great. So next one is, how do you see the future of agriculture in countries like India?
That's a good question. I don't know that much about agriculture in those countries. I think a lot of the challenge there is around, like there's, agriculture in the US is relatively efficient. We can grow at really large scales through machinery, through like crop genetics, and through really detailed understanding of of plant health. So you know exactly when you apply water and when you apply fertilizer and pesticides, and so you can apply all that in the most limited manner possible. So I think probably taking a lot of those efficiency things and moving them to India is most likely the answer. I would imagine that labor is less of a challenge there than it is here.
Great. So this next question looks from like LVIB. In order to be effective at harvesting, are there any specific requirements for sowing the seeds and/or the farming surface? Also, will the product just for harvesting, or will it be used for other capabilities too?
So our goal is to make so the farmer doesn't have to change anything at all. So same seeds, same planting process, same bed shapes and everything. So no changes in the growing process. And what was the second part of the question?
Sure. Will the product be just for harvesting, or will it have the capability to sow too?
Just harvest.
Okay, great.
Yeah, harvest is in terms of the labor cost, harvest is a much bigger problem.
Yeah. So the big thing it looks like is it's a nice drop-in replacement for the current infrastructure.
Correct.
No modifications, which saves farmers lots of money by not having to basically restructure their entire farming process. Yeah,
and it's actually less about saving them money and more about increasing the revenue. So we want to take the 20% of strawberries that are being left to rot in the fields because they can't find enough people to pick them and make it so that we can get those off the field into clamshells and so they can sell them. And then make it so that they can increase the size of their farm because they're no longer as constrained by their labor supply. And so if we do that, if we can find a way to make their business more efficient and increase their revenue, then we don't need to charge a lot less. We can charge the same as what they're paying now, which means good revenue for us, and it means their businesses go well.
Great.
I think that in general, if you're a startup, it's best to try not to compete on price and try to compete on quality instead.
That's a good point. That's a good methodology to live by. I agree. Next question is Traptic hiring?
We are, yeah.
You are?
Looking for good hardware and software engineers.
Great. So
Yeah.
we have a huge community of over 1,200 people.
Okay.
If you like, you can send me that job posting. I'd be happy to spread that with our community. We
Yeah.
have a lot of professional and aspiring roboticists, so I'm sure a lot of people here would be interested.
Okay, yeah. I'll send something by. And people can also email me if they want.
Sure.
My email address is Lewis, that's Lewis,
Okay.
at traptic.com, TRAPTIC.
Perfect.
Yeah.
And are you currently looking to raise another round of funding, or are you?
Yes, we're going to raise another round of funding starting next month.
Perfect.
Yeah.
Cool. Well, I think that's all the questions that we have for right now.
Okay.
So thank you everyone for joining the robotics Q&A today. If you want to learn more about robotics, please visit udacity.com/robotics. And also don't forget to check out our Slack community at robotics.udacity.com. Lewis, thank you very much for being here today. Appreciate your time.
Thank you for your time.
Meeting you.
It's been a lot of fun.
Yes.
Yeah, and if anybody has any questions, feel free to send me an email.
Perfect. Great. Thank you.
Thank you.